All right, we're going to start on problem 26. Piecewise functions f and g are given below, and it says find each of the following. So the first is looking for f plus g of minus 1. So this is going to be equivalent to f of minus 1 plus g of minus 1. And so to find f of minus 1, I'm going to look at the function f of x, and I'm going to start by looking for where is minus 1 over here, and then that's going to tell me which of the functions I need to use. I need to use this function here. Whoops, that's a crazy pen. This function here, okay? So I'm going to get 2 times minus 1 plus 3. And then for g of minus 1, again, I'm going to look over here and see where is negative 1. It's here. So I'm going to use this function. So that gives me 1 over minus 1. So this is equal to negative 2 plus 3 minus 1. That gives me 0. So the correct answer here is 0. And then 26b is g of f of 0. So to evaluate this, we're going to first evaluate f of 0. And so to evaluate f of 0, I'm going to start by looking for where the 0 shows up in the function f. So 0 would be between negative 1 and 2. So I'm going to use that equation there. So that would be g of, I'm going to plug 0 into that. So 2 times 0 plus 3. So this is g of 3. So then to evaluate g of 3, I'm going to look over here and I see where is 3. 3 is greater than 0. So I'm going to use this function here, x cubed. So this is going to be 3 cubed, which is 27. 26c, it's f composed with g evaluated at 2. This is equivalent to f of g of 2. So to evaluate, I'm going to start by evaluating g of 2. And so I'm going to look here and see where is 2 on g. 2 is greater than 0. So I'm going to use this function here, x cubed. So it's going to be f of 2 cubed, which is f of 8. And then to evaluate f of 8, again, I'm going to look over here at my function and I see where is 8. 8 is greater than or equal to 2. So I'm going to use that function for x. So this is equal to 4 times 8, which is 32. Okay, so that's 26. I'll move on to 27. So I'm given a f and a g, and I want to find a new function and its domain. So f of x plus g of x is going to be equal to 1 over x plus 1 over x plus 3, and I can leave it just like that. And the domain will be, well, it'll be everything except for except for 0 and minus 3. So if I draw that out on a number line, that's going to be anything less than minus 3, anything between minus 3 and 0, and anything greater than 0. So if I write that in interval notation, that'll be negative infinity to negative 3, union, negative 3 to 0, union. Let me erase this get this out of the way. 0 to infinity. And for the next one, I have f composed with g of x. And so if I look, that's f of g of x, which is equal to f of 1 over x plus 3. So I want to put 1 over x plus 3 into the function 1 over x, so that's 1 over x plus 3. So to simplify this, I'm going to multiply the numerator and denominator by x plus 3 to to clear out that denominator. And so what that gives me is so I'm basically multiplying by 1 in a creative way to get this. So I'll have x plus 3 on top, and on the bottom I'll have x plus 3 over x plus 3, which divides to make 1. So this is just equal to x plus 3. And so what is the domain of that function? Well, if I only had just that it was x plus 3, that would be everything. But since I started with this function here, since I started with that, I still have to leave out the x equal negative 3. So it's going to be this. It's basically everything except for negative 3. So when you're combining functions like this, you do still have to take into account like the domains of the original functions. So the domain here will be negative infinity to negative 3 union negative 3 to infinity. Okay. And for the last one, it's g of f of x. So what is that? That means I want to plug f of x in for g, so it's 1 over x plus 3. And so to simplify this, I probably want to multiply the top and bottom of this fraction by x, just to clear out that x in the denominator. So that means I'll multiply that x by the whole denominator. So what that gives me is just an x on top, and on the bottom, when I distribute that x, I'll have 1 plus 3x. And so again, we're definitely going to have to leave out x equals 0 because of this part of the function there. So when I think about the number line, I'm going to have to leave out x equals 0. But also, look at this new denominator. The 1 plus 3x needs to be not equal to 0. So negative 1/3 will also be, because if I let 1 plus 3x equal 0, I'll get x equal to negative 1/3. I need to throw that one out as well. So that will give me this for my domain, which will be negative infinity to negative 1/3 union negative 1/3 to 0 union 0 to infinity. Moving on to number 28. It says, let f of x equal g of h of x. So for each part listed below, find two possible sets of formulas for g of x and for h. So assume that g of x is not x and h of x is not x. So basically here we need to be thinking about like what is our inside and outside function. So let's try to dissect this f of x. So if we have f of x is equal to 3 over 2x plus 1 plus 5. Well, one way we could see this is we could maybe see this bottom part as a thing altogether. And so I could think about it like, I could think about the inside part being 2x plus 1. So if this would equal to g of h of x, then the inside part, the h of x, would be 2x plus 1. And the outside part would be 3 over the inside part, which I'm writing as x, plus 5. So the outside part is like 3 over x plus 5, where the inside part is the 2x plus 1. So that's one way to see it. Another way to think about this might be, let's see, is there another potential inside function? So we could maybe think of it as 3 over 2x plus 1 plus 5. We could maybe let this part be the inside function. And maybe we could say h of x is equal to 2x and g of x equals 3 over x plus 1 plus 5. So that's another possibility. We could also let f of x equal 3 over 2x plus 1 plus 5. And I could think about this whole thing as being the inside part, which would mean that h of x equals 3 over 2x plus 1. And then g of x, the outside part, would just be x plus 5. So those are two other possibilities for this as well. So if I'm looking at the solution answers here, it used this second one. But this is also a third one that could be a possibility. Okay, so I'll just put the answers that's on the review sheet just so you all aren't confused, but there are more than these two answers that are given possible. Oh, actually, so this answer is slightly different from the answer on the sheet, but it's also correct. So, okay. So, yeah, so there are lots of possible answers on that one. Okay, so let's look at the next one. We have f of x equals 2x plus 1 to the fifth. So when I think about what the inside part could be, it could be that inside part. It could be like the h of x is equal to x plus 1. And then the outside part could be g of x equals 2x to the fifth. So that's one possibility. The other one I could think of is I could let all of this be the inside part. So I could let h of x equal x plus 1 to the fifth, and then g of x would just be 2x. So that would be another way to see that as a composition. I think that might be the only two ways you could really see that one. There's not a lot going on in that function. Okay, so that's it for that one. Let's take a look at number 29. It says, let f compose with g equal that, and g compose with f equal that. Find formulas for f and g. Okay. So, all right, so let's say that f of g of x equals 3 square root of 2x minus 1. Okay. So a possible inside function might be the 2x. So let's think about that. So if we let g of x equal 2x, then that means f of x equals 3 square root of x minus 1. But then when I do g of f of x with the one I've got there, I want to plug f inside of g. It would be 2 times 3 square root of x minus 1. So that's not equal to what I'm trying to get there. Okay, so what's another possibility? Okay, let me try again. Say I let my inside part be all of this, square root of 2x. So if I let g of x be the square root of 2x, then what's my outside part? That means f of x equals 3x minus 1. Okay, let's try that. So then if I did g of f of x, I want to plug that f inside of that g. So it's going to be square root of 2 times 3x minus 1. That's looking better. And if I simplify that, that would be square root of 6x minus 2. So that's what I needed. So my g is square root of 2x, and my f is 3x minus 1. Okay. So that's it for that one. All right, on number 30, I'm using the graphs of f to find each of the following. Okay, so f inverse of 3. Okay, so that means that my 3 is an output value. So I'm looking for what is the input that gives me 3 as an output. So, so I want to go over here to 3 as an output value and see what input value for f gives me the output value of 3. And if I'm looking at that correctly, it looks like it's 6. So 6 is the input value that I input into f that gives me the output of 3. Okay, what about g inverse of 4? What's that going to be? Okay, So that 4 is an output value for the function g. Okay, so I'm looking at 4 and I want to see what input value gives me the output of 4 for g. And I can see it right there. It's at 0. So when x is 0, g of 0 is 4. Okay. All right, the next one is getting a little bit more complicated. This is g of f inverse of 5. Okay, so let's just start from the inside. Okay, so to evaluate this, I can see that this 5 is an output for the function f. Okay, so let me erase what's going on over here. And so 5, so I want to look over here and I can see that oof. Is that at 2? Maybe? Okay. So when x is 2, the output is 5. So this should be g of 2, because when I input 2 into f, I get the output of 5. Okay. And now 2 is an input for g. So now that 2, this is now an input for the function g. So that 2 is here, and so I'm inputting it into g, and I get an output of 3. So that's what I'm looking at there. So I'm asking, what is the value for g for the same x value that gives me the output of 5 in f? Okay, well, maybe that didn't clarify saying it that way. Okay. So next, I want to solve for g of f of x equal 3. I want to solve that for x. Okay, so let's think about this. G of f of x equals 3. Okay, so that 3 is an output for g, right? So what input value for g gives me an output of 3? So let's go over here to the graph and see, when does g have an output of 3? If I look at it, it looks like at x equal 2. So what that means is this thing in here needs to be equal to 2. So that's telling me that f of x needs to equal 2 in order for g of f of x to give me 3. So then I know that that 2 is an output for f. And I'm looking for the input, the x value that gives me that output for f. Okay, so let's go over here to 2. And then this is a long thing here. So all the way over here. And it looks like it's 8. The dots are a little hard to see, but I think that x equal 8 is the answer. So if I solve that, I'll get x equal 8. All right, so now we are on number 31. It says, let y equals f of x equal 2 square root of x minus 5. So I want to find f inverse of y. Okay, so let's write our function out. So we have y equals 2 square root of x minus 5. And now I want to solve that for x to get my inverse function. So I can divide by 2. Sorry, minus 5. And then I can square both sides. So y squared over 4 is equal to x minus 5, and then I can add 5. So x equals y squared over 4 plus 5. And so that is my inverse function. And then to figure out the domain and range, we probably need to start with the domain and range of f. So if we go back to our original function f and look at it, what is its domain and range? So let's kind of go over here and think about that function. So I know that the stuff under the square root needs to be positive. So x minus 5 needs to be greater than or equal to 0, which means x is greater than or equal to 5. So that's the domain of f is 5 to infinity. So the domain of f is going to be equal to the range of f prime. Okay, but thinking about the range of f is a little bit more complicated because, so to get the range of f, we would need to like plug those values in. So I can see that the smallest value, if I plug in 5, I'm going to get 2 square root of 5 minus 5, which is just 0. And then as I plug in bigger and bigger values, I can see that that thing's just going to go off to infinity. So the range of f is going to be 0 to infinity. So that means that for my inverse function, the domain of f inverse will be equal to the range of f. So it's 0 to infinity. And the range of f inverse will be the domain of f. So it switches. So 5 to infinity. So there's your domain and range for f inverse. All right, so number 32 says salt water is flowing into a large tank and the concentration of salt in the tank is given by that function, where t is the time in minutes after the salt water started flowing into the tank. Okay. Find f of 20 and explain what it means. Okay, so c equals f of 20 equals, it's going to be 1.2 times 20 over 100 plus 6 times 20. So I'm just going to plug that into a calculator. And when I do, I got 6 over 55, which is approximately 0.10909. Repeating. So what does that, oh, it says round to 4 decimals. Okay, sorry. So if we round to 4 decimals, okay. So that should just be a 1. And then what are the units? Well, that is a value of C. So C stands for the concentration of salt in the tank in pounds per gallon. So 20 is a value of time, and that's in minutes. So after 20 minutes, the concentration of salt is 0.1091 pounds of salt per gallon of probably water, I guess. Yeah, salt water. Okay, so pounds of salt per gallon of water. Okay, and then it says find f inverse of C. Okay, and so if this is C equals 1.2t over 100 plus 6t, I can multiply that over. So I get, sorry, let me do the work down here. So I get C times 100 plus 6t equals 1.2t. Then I can distribute that over. So I get 100c plus 6ct equals 1.2t. Now, what am I solving for? I'm solving for t here. So I want to make sure that those t's are on the same side of the equation. So what I'm going to do is add and subtract terms until all the terms that have t in them are on one side. So when I do that, I'm going to get 6ct minus 1.2t equals negative 100c. Now I can factor out the t. So that gives me 6c times, sorry, that's not what I need to do. T times 6c minus 1.2 equals negative 100c, and then I can divide that over. So my final answer is t equals negative 100c over 6c minus 1.2. And so that is my inverse function. So, and then we're going to use that in part C, which unfortunately is in the next video.